About dual booting for testing and curiosity with dynamic system updates. The last slide in the presentation will contain a QR code to this presentation, so you can refer back to any links or any instructions that are given on any of the slides. So, the outcomes of the talk, I will cover what generic system images are, or GSIs, which is the prerequisite knowledge for dynamic system updates, or DSUs. I'll also give a walkthrough on how to apply a DSU to your device, and an explanation on how they can be useful in your development workflow. So who here has heard of dynamic system updates before this talk? So a few of you, but basically it's not your fault if you haven't heard of them before, because Google haven't really made much of a song and dance about it. In fact, the documentation for DSU is on an untraveled part of the Android developers website. So where I got the inspiration for this talk is I'm on a Slack group, and someone posed the following question. If you use Pixel devices for testing, is it possible to go back and forth between the Android versions? Can I flash the latest beta, test my app, and then flash the latest stable again? And I replied, yes, you can, but a better idea might be to use dynamic system updates, where you can have a primary version installed, and you can also have a second installation, a bit like dual booting. And the reaction to my comment was there's 22 people hit the Today I Learned button, TIL. So that kind of gave me more of a clue that not many people know about dynamic system updates. And I want to also thank Eric Hellman for bringing this feature to my attention while we're working on a previous project. So what are dynamic system updates? Well, firstly, we need to talk about generic system images. So what are generic system images, or GSIs? So from the Android developer website, it describes a generic system image, or GSI, is a pure Android implementation with unmodified Android open source code project, AOSP code, runnable on a variety of Android devices. So why are GSIs useful? Well, AOSP is a canonical version of Android, so testing against the AOSP version of Android gives you a baseline for support. Bluetooth, Wi-Fi, and sensors are tricky to test in the Android emulator. There's ways of mocking them, but it's tricky. So if your app supports hardware features, then testing on device is non-negotiable. Some devices can support GSIs from multiple versions of Android, regarding of the primary device installation. But we'll come back onto DSUs later, because they make the process even easier to flash. So the prerequisites for generic system images is that the bootloader is in an unlocked state. This means that your device will now fail Google Play integrity verification, meaning that some apps, such as banking apps, will refuse to function. So this is not suitable for your daily driver. Project Treble was a project within Android to decouple components within Android. GSI relies on this decoupling to operate. So you can determine if your device is Project Treble enabled by executing the ADB command that's shown on the slide. The device must have also launched with Android 9 or higher. There's some devices that launch before Android 9 that might support GSIs, but this isn't guaranteed. The GSI image CPU architecture must also match the CPU architecture of the device that the image is being flashed to. If it doesn't match, the process will fail. So use the ADB command that is given on the screen to determine what CPU architecture your device is. And I just want to draw your attention to the warning at the bottom of the screen, is that flashing an image which does not meet the requirements may result in the device becoming non-bootable, soft or hard brick. So soft brick being that it's recoverable, and hard brick meaning you've literally got a brick. So some device recommendations is, so this talk is mainly going to talk about Google Pixel devices, because that's the most traveled route for GSIs and DSUs. So I would recommend a Pixel 3 and above for GSI support. These can be picked up fairly cheaply, and also secondhand, even more cheaply. Perhaps even look at the Pixel A series as an inexpensive device to test on. Other OEMs do provide support, like for example, there is support within Samsung and some other OEMs as well, but I've only tried the instructions given in this presentation on Pixel devices, so I can't vouch for compatibility elsewhere. But do refer back to the prerequisites in the previous slide to give you a clue if the device will support it, but also just have a look online to see if other people have had a success with this as well on the image that you're interested in using. So how do we obtain a GSI? Well, Google has these official releases that are at the URL shown. They come in the varieties of pure AOSP code or the ones where it's AOSP but with Google Mobile Services already installed on the image. There's also ci.android.com. That's Google's public view of their continuous integration infrastructure for building Android. For some reason, the Android 15 and Android 16 don't show up on ci.android.com. I'm unsure what the reason for this is. And if you have the know-how and a powerful enough machine, you can actually build your own GSI images. You can make customizations to Android or to pre-bundle apps into the image if you want to. To flash a GSI is actually beyond the scope of this talk because we're going to be talking about DSUs. But for interest, there is no single set of instructions. It varies by OEM. Google have a set of instructions at source.android.com about how to do this for Pixel devices. But you also might have some success with flash.android.com. But again, this is going to raise data on your user partition, so don't use it on your daily driver. And it's also the possibility of soft or hard bricking a device if you're not careful. And now on to DSUs, what you came here to listen to me talk about. So what is a dynamic system update? So a dynamic system update, dynamic partitions are a user space partition in Android. The system can reallocate the size of partitions depending on its needs. As long as your device has enough free space, DSUs can make space for your guest image installation. The guest image is installed onto this new dynamic partition that's created, and once the installation has completed, the device can then be rebooted. And if it's successful, you should boot into your guest installation that you've installed through DSUs. If it failed, normally you should just end up back in your primary installation again. But be careful because DSUs can, in some circumstances, cause issues and brick the device. You can also easily switch between your primary and guest installations with relative ease. And so if your DSU image is your preferred installation, you can make it sticky, and we'll talk about that later on in the presentation. But things can always go wrong, so please back up your data first. But as you alluded to before, is that you want to specifically do this on a specific test device. DSU prerequisites. So the DSU featured was added in Android 10. The prerequisites are largely the same for what I covered before for GSIs, and that the device has to be Project Treble compliant, and also the CPU architecture and the image architecture must match too. You may not have to unlock the bootloader depending on the image that you're booting and what key it's been signed with. But I would probably advise you to unlock the bootloader anyway because it causes less problems later on. If the guest image passes the Android verified boot, then it should boot. But if the image does not boot, then you may need to unlock the bootloader and flash a new VB meta image. But we'll discuss that later on in the presentation. DSUs also include rollback protection. System images that have a security patch. System images have a security patch date stamp included in them. The date stamp on the guest system image must be newer than the date stamp of the image that's in the primary installation. So there's two ways of installing DSUs on the device. There's either using the DSU loader, which is a user interface on the device, or you can use a command line on your development machine. So naturally, the UI is easier to use and less opportunity to make mistakes, but you're limited to a small number of guest system images provided by Google. If your needs are simple, then use the DSU loaders images provided by Google, because they're probably fine for your needs. However, if you have particular requirements, for example, if you need to use an image that's not provided by Google, use the command line. Either way, you'll probably need to use the command line to prepare the device for using DSUs. So to prepare the device, these instructions apply to the Google Pixel line of devices. Our devices may vary in their instructions. This assumes that you've already enabled developer options and USB debugging on your device, and that the device is connected to your computer by USB. Don't perform the following steps unless you're okay with losing data on the device. So firstly, verify that you can see your device with ADB. Then reboot into the bootloader and wait for the device to be in fast boot mode. Then unlock the bootloader. After issuing the fast boot flash and unlock command, then follow the instructions on the screen to proceed. This will erase all user data on the device. Now we want to disable verified boot verification so that the guest image can boot regardless of the sign-in key of the system image. So we download a special build of VB Meta provided by Google at the URL that you can see on this slide. And then once we downloaded this, we can then flash this VB Meta image using the extra command line arguments that you can see here to disable verity and disable verification. And then the device is now ready to accept DSUs. So you should see a video on your screen here, on the presentation here. If we go to the Settings app, then we navigate to Developer Options, then the DSU Loader option. Then a list of images is presented to you. These will be GSI or GSI plus GMS, and you can choose whatever you want. You need to then agree to the terms and conditions, and then you can monitor the download and installation progress from your notifications. The download obviously depends on your internet connection, but the installation normally takes only a couple of minutes. So once the installation is completed, you'll then see in the notifications restart button, so hit restart. And then hopefully you'll have rebooted into your DSU guest image. And if it didn't boot, then as I mentioned before, you will usually return back to your main installation. This is usually what happens. But be wary of disaster. So if in the worst case scenario, you may soft or hard brick the device. To install DSU from the command line interface, firstly we need to prepare the image. So you obtain the image from whatever source. This could be from the GSI releases page or from ci.android.com, or maybe one you compiled yourself. Before the images can be installed, they need to be unsparsed. Some sources will give you the image already unsparsed. On Mac, you need to use the SimG2 image utility, which can be installed through Homebrew. On Linux, this will usually come through your distribution package manager. On Windows, no idea, but there'll be some way. I'm sorry, I don't use Windows. But if SimG2 image returns an error, this usually means that the image is already been unsparsed, in which case delete the 0-byte file that has been produced by SimG2 image and then rename the image to system.raw.image. And then before we can then send the image to the device, it needs to be gzipped. Once it's gzipped, we can then use ADB push to send the image to the device's external storage. Verification activity is an activity on the system which is used to install DSUs. So to install the image that we've just pushed, we use the ADB command that's shown here to start verification activity, passing in the start install action and passing in these arguments as intent extras to tell it where to find the gzip system image, the size of the non-gzipped system image, because it wants to know the un-gzip size, and what size that the user data storage is supposed to be. The WC command that you can see here, executed in line within the command here, is used to evaluate the size of the system raw.image file. If that doesn't work in your system, you can substitute this with the file size of the image, but the size to pass in here is the byte size of the image. And if required, you can also tweak the size of the user data partition. To install the DSU from the command line interface, once you've done that, you've started verification activity. You'll see the installation notification in the notification drawer, just like you did on the DSU loader method. But hopefully there are no errors, but common errors might be that the size of the image is wrong, failed verification, not enough space in the disk. But assuming all is well, like the DSU loader, then you can hit the restart button in notification. Once the device is rebooted, then hopefully it was successful and you're now in your DSU guest installation. So to make the image sticky, by default DSU image installations are not sticky, so if you reboot you'll end up back in your primary installation again. The data is preserved, but however you can enable sticky mode so that you automatically boot into the guest installation on boot. So execute the given ADB command shown in the slide here while you're booted into the guest image, not from your primary installation. And likewise, just like making it sticky, you can also make it unsticky to go back to your primary installation again by executing the free commands that are shown on the slide here. So disaster recovery. So if you do have any issues, then you can employ some disaster recovery techniques. So as alluded to earlier, the process is destructive to user data. So take a backup of your data, but even better, use this on a dedicated test device. Failure should not usually result in bricking, but this doesn't mean it can't happen. Normally, failure should result in you go back to the main installation where you started in the first place. But for Google Pixel devices, Google provides factory images with the flashing instructions for every device that they've ever released. In most cases, this should get you back to a clean factory state if things go wrong. This presentation concentrates on Google Pixel devices, as I mentioned before, but so other OEMs will have their own recovery methods, so please consult your OEM's instructions on how to recover the device. In the worst case, but unlikely scenario, you could hard brick the device, so please be careful with the commands that you're sending. Some tips is that you may wish to move between Android versions. If you do so, then install an old version of Android in your primary installation. This is because of the rollback protection that I mentioned earlier, where it looks at the security date stamp in the image and also the security date stamp of the installation. So use an old image so that you could always pass the rollback protection. As alluded to before, it's best not to use your DSU as your daily driver because of unlocking the bootloader. This disables some device security protections. Also the DSU loader UI will likely present Android build numbers rather than the more publicly understandable Android versions to you. To map between the build numbers and the Android versions, go to the URL shown at source.androids.com. Sometimes the instructions in this presentation and the Android developer site don't always result in success for you. You may need to search for help or use your own intuition or give up. Sometimes there's issues. So I'll quickly go through a couple of use cases about why this might be useful to you. So as demonstrated in this presentation, DSUs can make it relatively easy to run a guest system image on real hardware alongside your primary installation. However, beware of some gotchas like images not booting, for example. Don't expect an older Pixel device to magically be able to run the latest version of Android. But nevertheless, using the guest images allows you to access real hardware such as sensors, Wi-Fi and Bluetooth, etc. So this means you can test where the emulators cannot across different platform versions. As mentioned earlier, AOSP is the canonical version of Android, so you can test against the gold standard baseline before evaluating paired device support. And because you can easily switch between different versions with DSU, it's possible, depending on your setup and needs, to maintain a smaller bank of devices in your test lab, because you can just switch between versions on a single device. Another use case is that when you run a production version of Android, the system is signed with private vendor sign-in keys, and the device is usually in a non-rooted state. However, for testing and debugging builds of the platform, user data or engineering builds, they are usually signed by AOS-provided test keys. These builds are locked down are not locked down as much as production builds and are usually rooted. Many APIs are hidden or restricted by permissions, so you can only obtain if you're signed with the same key as the system or if you're considered a privileged app. Because the test keys are publicly in the AOSP repository, you can easily sign your APK with the same key as the user debug built system. In the user debug system, because the production protections have been disabled, such as the ability to access root, you can remount the system as writable, so you can push your APK to the priv app installation location. So why do this? When messing around with a user debug system, you can learn a lot, like I did, about how Android works internally. It's fun and perhaps satisfy your curiosity. And with DSUs, you don't need to worry about breaking anything, because if you mess anything up in the system, you can just return back to the host OS and install a new DSU image and try again. Also, if you're writing system-level services for your day job but don't have access to the test hardware yet, and then the debug, so DSUs with user debug images gives you opportunity to write these system services. This is the whole reason I learned about DSUs in the first place for a previous project I was working on, because we didn't have access to the test hardware, so we used DSUs to write critical system services. So thank you for coming along to my talk. That's the end. This and as mentioned, my first Android and droidcon talk. So thank you very much for coming along. Here's some links on the screen. The first two links are basically show you how to do the GSIs and also DSUs, much like what was shown in this presentation. But the other two links are about how they are implemented within Android, if you're curious to know how it works underneath the hood. And the QR code that's shown on this slide here links you to this presentation, so you can reference the URLs and the instructions. Thank you very much. Any questions? Yeah, I've got to take questions if you want. Yep. I've not actually tried that with Android Automotive. I think it should be possible. The only thing is in the vehicle hardware abstraction layer, how that interfaces. So if you have a mock version of the vehicle hardware abstraction layer, then I think it should work. But I haven't actually tried that specific route myself. Any other questions? Cool. Well, thank you for coming along.